In this video, we're going to tackle solving radical equations. So this is the actual application of solving radical equations rather than just the concept of it. We'll go through and actually do it. Prereqs, the same prereqs to the conceptual video. You have to know all about radicals, solving equations, and quadratic equations. I'll start simple and nice here. So we have 4 times the square root of z minus 8 is equal to a negative 2. First thing we look for is if there are any decimals or fractions that we can clear out quickly, and there are not. Then we see if we can clean up or combine like terms on the left hand side or the right hand side. We cannot. And then we check to see if there are variables on both sides of the equation, which there are not. Okay. Now, since I know all the variables are on the left hand side, I just see if there are more than one term contains a variable, but nope, only one term contains a variable. So that means I'm going to untie this knot. Let's list out what happened to z. The first thing that they did to kind of throw us off the trail of finding what z is, they took the square root of it. After they did that, they multiplied it by 4. After they did that, they subtracted 8. Notice the order of operations that you see right here. Exponents, multiplication, subtraction. Now, that's how they tied this all up in a knot. To untie a knot, we just do the opposite of each of these actions in reverse order. So we're going to do the opposite of subtracting 8. We're going to add 8. We'll do the opposite of multiplying by 4. We're going to divide by 4. And finally, we're going to do the opposite of taking the square root. We're going to square both sides. So let's go ahead and do that. Add 8 to both sides. And we get this wonderful 4 times the square root of z is equal to 6. And now we divide both sides by 4. Just following my little list of things to do here. 4 over 4 just becomes 1 on the left hand side by design. So we get the square root of z on the left hand side. On the right hand side, this fraction will reduce. That's 3 halves. And finally, I tell myself I'm going to want to square both sides. I'll go ahead and do that. So in the end, I get that z is equal to 9/4. Now, always what you should do is check your answer when you end up squaring both sides of an equation. You must check your answers. So please do that here. It'll be a very quick check. Just find out what 4 times the square root of 9/4 minus 8 turns into. Well, that's 4 times the square root of 9/4 is 3 halves. Minus 8. 2 goes into 4 twice. That's 6 minus 8. That's a negative 2. That works out. There we go. Very quick check. But you have to do it. Alright, again, take a look at my next victim here. Let's see. Any fractions? No. Any decimals? No. Great. Can I clean up the right hand side? Nope. Can I clean up the left hand side? Not really. If you look inside this square root here, those two terms will not combine, so that's stuck. And on the outside, these are not like terms. This is a 5. This is 2 times junk. So these two terms cannot combine. That 2 has some issues attached to it. So we can't combine terms. Finally, I just take a look around and see how many versions of my variable, how many occurrences of my variable there are. There's only one occurrence right there. So that means I can untie the knot. There's no special technique needed here. So let's list out what happened to w. As I look through this, the first thing that I see is that it got multiplied by a negative 2. So the first thing I see is it got multiplied by a negative 2. After it got multiplied by a negative 2, they added 6 to it, whoever they is. Then they took the square root. The reason why I know that you're thinking, wait a second, isn't this the order of operations? Should we take care of exponents first? What you're doing is you're centering on w. So you start with w and say, what's the first thing that happened to it? Oh, it got multiplied by that negative 2. And then it got added to by 6. Now this whole entire picture, 6 minus 2w, they took the square root of. We are technically following the order of operations because the order of operations says, look inside the square root first and tell me what happened. and then apply the square root. All right. Anyway, after they took the square root of it, they multiplied that, this square root of junk here, by a negative 2. So let's go ahead and write that down. They multiplied it by a negative 2. Finally, a lot of things they did. They added 5 to it. 5 out front means adding 5, plus 5. So let's go ahead and untie the knot by undoing every single thing here, doing it in reverse order. So let's see, instead of adding 5, we'll subtract 5. Instead of multiplying by a negative 2, we'll divide by a negative 2. Instead of taking the square root, we'll square. Instead of adding 6, we'll subtract 6. And instead of multiplying by a negative 2 again, we'll divide by a negative 2 again. All right, let's do this. First thing I have on my list is subtract 5 from both sides. If I do that, I get this beautiful negative 2 times the square root of 6 minus 2w is equal to 8. Now there is something that should be said, well, we'll see it in a moment. Next thing that we're going to do is divide both sides by negative 2. And you see on the left-hand side, the negative 2 over a negative 2, that turns into a 1. So this becomes the square root of 6 minus 2w is equal to a negative 4. Now, pause this video for a moment and see why there's no solution to this. If you don't see why there's no solution to this, then follow me forward. But it's always important, or maybe not important, but always a good tactic when solving radical equations to check, once you get the square root of junk is equal to number, to check to make sure that number is positive, because square roots can only return positive numbers. I already know right now there's no solution. There's no solution to this, because a square root always equals, basically is always greater than or equal to 0. Okay, square root of stuff is always greater than or equal to 0. But here we have the square root equals to a negative number. Can't happen, so there's no solution. But let's suppose you didn't see that. If you continue following this list of steps, we'll square both sides. And you get 6 minus 2w, because the square undoes the square root, is equal to 16. We will now subtract 6 from both sides. And we'll get negative 2w is equal to 10. And finally, we'll divide both sides by negative 2. Sorry for the voice cracking. I am sick. Well, so negative 2 over negative 2, that's just 1. And so we get 1w is equal to a negative 5. Now remember what you should do. Whenever you square both sides of an equation, you have a risk of introducing an incorrect solution. So let's check this solution. So I go back to the original equation. Instead of w here, I'll go ahead and plug in to its place a negative 5 and see what happens. So if I do that, I will have 5 minus 2 times the square root of, that's 6 plus 10, or in other words 16, which is equal to 5 minus 2 times 4, which is 8, which gives me negative 3, which is not actually equal to 13. So that's the issue. This is not a solution. We call that an extraneous solution, as I mentioned in the previous lecture. Extraneous meaning that we've introduced it incorrectly when we squared both sides. That's why you should always check your work. But we could have noticed, by the way, that we were going to have no solution again way back in the beginning here. I have to change my eraser size to a very small eraser to do this. Way back in the beginning, we could have noticed that we wouldn't, or not beginning, but at this point right here, we could have noticed this wasn't going to happen, right? The square root of a number is never negative. So let's try another example here. In this example, again, I have one version of my variable, which means that I can undo what's happening on that side of the equation. First thing I try to do is I look at both sides, see if they're fractions or decimals, which there aren't. And then I look to see if there's any terms that can be combined. This 1 and the 6 cannot be combined because that 6 is tied up in a multiplication. And remember, before any type of addition or subtraction, you have to take care of multiplication. So there's no way that 6 times root x plus 1 can be simplified any further, so these two are unlike terms. So now I have to think about what happened to x. When you look through this, focus in on x first. The first thing that happened that somebody tried to do to kind of hide the value of x from us is they added 1. The next thing they did after they added 1 to x, they took the square root. And after they took the square root, they then multiplied by a negative 6. And after multiplying by a negative 6, they added 1. That's this last little bit right here. So again, we're going to undo this stuff in the opposite order. So I'll start up here. And I have to undo the last thing that they did. They added 1 here, so I'm going to subtract 1 from both sides. The next thing I have to untie is a subtraction of 6, so I'm going to add 6, all inverse operations. Next thing I'm going to do is undo the square root, which means I'm going to square both sides. And that is the step where, in the last example, we saw we can introduce an extraneous solution. So this is cause for checking solutions always. And then the fourth and final step, they added 1, I will subtract 1. So let's go ahead and do this. First step, I tell myself, is to subtract 1 from both sides. So when you do that, you get this wonderful negative 6 square root of x plus 1 is equal to 14. And then I tell myself next thing, so this one's done, add 6, not add 6. Man, everybody's probably thinking that I don't know what I'm doing here. We multiplied, I even said it, I remember saying we multiplied by a negative 6 in this step. So going back here, remember, first thing that happened to x, we added 1, then we took the square root, then we multiplied by a negative 6. It looked like I was saying subtraction by a negative 6, so that's why I convinced myself that over here was right. Let me just erase this and put in the proper thing here. So let's see, we would undo addition with a subtraction. We'd undo multiplication by dividing both sides. There we go. Yikes. That was near tragic. So I'm going to divide both sides by negative 6. And you see the negatives will cancel. 6 over 6 is just 1. So the left-hand side turns into the square root of x plus 1. The right-hand side, I'm going to reduce that fraction. Both top and bottom are divisible by 2, so that'll be a negative 7 thirds. And remember, it's always just good form to write negatives in numerators or out front. A lot of people do not like negatives in denominators, so it's just good form to leave it out front. Not that it's incorrect, it's just good form. Now before I go any further, I just want you to, again, once you get to a point where you have the square root of something with a variable equals a number, you should always check to see if that's feasible. Notice that this number here is negative. Square roots never equal negative numbers, or negative real numbers, I should say. So therefore there will be no solution. I already know right now there's going to be no solution. However, I do have a lot of students that just continue forward blindly, which is understandable. You just kind of, especially during an exam, you don't really think, you're just kind of moving along. So if that's the case, let's see what would have happened. Well, let's see. We're done with this step. So the next step was to square both sides. So if we squared both sides, we would get on the left-hand side, the square and the square root cancel, we get x plus 1. On the right-hand side, negative 7 squared is 49. 3 squared is 9. And then subtract 1 from both sides. So let me check this off. And I'll subtract 1 from both sides. Subtract 1, subtract 1. Now 1 is the same thing as saying 9/9. So I'm subtracting 9/9 from both sides. So this gives me that x is equal to 49/9 minus 9 of those ninths will leave me with 40 of those ninths. But remember, always check your work because you squared both sides. So if you try to check this work, it will not actually work out. because what happens is you get 1 minus 6 times the square root of 40 over 9 plus 1, which is the same thing as 9 over 9. Well, let's go ahead and simplify this down. That's 1 minus 6 times the square root of 49 ninths. And square root of 49 ninths is 7 thirds. 6 times 7 thirds, well, 3 goes into 6 twice, so that's going to be 1 minus 14, which is going to be a negative 13, which is not equal to 15. So that's an extraneous solution. Again, no solution, right? But you know how much, did you notice how much extra work we had to go through to solve this when we didn't take the time to recognize that a square root can't equal a negative number? So whenever you're solving radical equations, it's always good to keep an eye out for that. Now we have our first foray into a radical equation that has two different versions of our variable. What I mean by this, well, I'll just show you. Now recall that we had mentioned a list of techniques, or maybe I shouldn't say list of techniques, but a list of ideas when you want to solve an equation. Clear fractions or decimals, clean up left and right hand sides by getting rid of parentheses and combining like terms if you can. And then, if there are variable terms on both sides, move them all to one side. Once you do this, if this leaves you with only one occurrence of your variable, untie the knot. Otherwise, you have to resort to special techniques. And with radical equations, the special technique you're going to use is to isolate one of the radicals, square both sides, rinse and repeat, meaning you'll end up with another radical, isolate that, and also square again. And this process might continue another 2 times or something like that. So looking at this example, there are no fractions, no decimals. And on the left-hand side, I cannot combine like terms. There are no like terms. On the right-hand side, there are no like terms. And I also see that if I were to try to move anything between sides, nothing would combine. In other words, as an aside, if I subtract 2x from both sides, I'd get this. Some picture with a root 40 minus 3x on the inside of it, and then I'm subtracting 2x from that. And these two terms can't combine because this 2x is free outside a radical. And this 3x here is inside a radical, so they cannot be combined. There's no combining. These are not like terms. So once I realize that no matter how I kind of move things here, I cannot get these terms to combine, I immediately think isolate a radical, square both sides, and I might have to isolate a radical again and square both sides again. That process might continue. If I'm lucky, I won't have to do that. So in this case, you cannot use our untie the knot technique yet. It may turn out that you can later on, but at least at this point, because we have two different versions of our variable that will not combine, you cannot use that untie the knot technique. So I'll start by squaring both sides, because that's the only way I'm going to get rid of the radical. Now remember, 2x minus 5 quantity squared is the same thing as 2x minus 5 times 2x minus 5. Be very careful of that, because I, for one, as an instructor, hate when students write that as 4x squared plus 25 or minus 25. And I mark off all credit when students do that, because these are basic algebra skills. You should know that this means an object times itself. Distributing through, and I'm going to do it very quickly, distributing through we'll get 4x squared minus 10x minus another 10x, so that's minus 20x, plus 25 is equal to 40 minus 3x. Again, I'm going to move all variable terms to one side. So I'm going to add 3x to both sides. I'll even write that in here. Add 3x to both sides. Notice how I stack it with the terms that have only a single power on x. And so this gives me 4x squared minus 17x plus 25 is equal to 40. And I take the time to look through this and see if anything else on the left hand side will combine or anything else on the right hand side will combine. That's a big no so far. And then I ask myself, how many different versions of my variable do I have here? Well, I have two different versions. I have an x squared version right here and a single powered version of x right there. That means I still have, this is still a special technique to solve this equation. In other words, I can't say what happened to x and list out all the things that happen to x. I have to resort to special techniques. And this is quadratic. And the special techniques for quadratic equations, we're first going to isolate everything on one side, so move everything over to one side and set the right hand side or the left hand side, whichever you prefer, to 0. And then you're going to either factor that quadratic, if it can be factored, or use a quadratic formula. So let's go ahead and move this 40 over, subtract 40 from both sides. And I get, let's see, this implies I have 4x squared minus 17x. And let's see, 25 minus 40 should be a negative 15, I think. Equals 0. Now I'm going to see if that factors. I know that 4 factors into 2 and 2, or 4 and 1. And 15 factors into 3 and 5, or 1 and 15. So not very many choices. That means that this should be a quick factorization if it does factor. Let's try the 2 and 2 first. So 2 and 2. And let's see if 3 and 5 fit in there nicely. If I chose 3 and 5, let's see. 2 times 5 is 10. 3 times 2 is 6. No way to combine 10 and 6 to become 17. So this is not the proper factorization. I'll just go ahead and cross that out. So let's try the 1 and 15 now. Two times 15 is 30. 1 times 2 is 2. So 30 and 2. No way to combine those to become a negative 17. So again, I'll just take those two options out. So obviously the factorization, if it does factor, doesn't start with a 2 and a 2, because I've already wasted all my tries for 2 and 2. So let's try the 4 and 1 factorization. 4 and 1. By the way, these were supposed to have x's on them. I just kind of insert them later on. So let's try this. Now, because these two numbers are not the same, when you write 3 and 5, you have to also write 5 and 3. It makes a difference. So let's try this. 4 times 5 is 20. 3 times 1 is 3. 20 and 3. Is there any way to make 20 and 3 become 17? Yep, sure is. We want actually a negative 17, so I'd like it to be a negative 20 and a positive 3. Double check your work here. 4x times 1x is 4x squared. So that's this business right here. Let's see. 4x times a negative 5 is negative 20x. Plus 3 more of those x's will give me a negative 17x. So that's right there. And finally, positive 3 times a negative 5 is a negative 15. That's that one right there. So this actually does factor to 4x plus 3 times x minus 5 equals 0. Now that we know it factors, and let me just erase off most of this other junk on here. Now that we know it factors, we can say, using the zero factor property, that if two objects multiply to become 0, then one of them must be 0. Either 4x plus 3 is equal to 0, or x minus 5 is equal to 0. They both can be equal to 0, or maybe one of them is extraneous, because we squared both sides initially, so we might have a wrong solution in here. Solving each of these, I'll get x equals a negative 3/4, or x is equal to 5. And you have to check both of those solutions in the original equation. So check always with the original. Always in the original equation. So let me go ahead and erase off these powers here, and let's take a look at this original equation. So let's do the negative 3/4. We're just going to have to do it. So negative 3/4, if I plug that in, of 2 times a negative 3/4 minus 5, which, by the way, 2 goes in that 4 twice, so that's negative 3/2 minus 10/2. So negative 3/2 minus 10/2 is a negative 13 halves. Now, I want you to notice something here. Before I even plug into the right-hand side, that's supposed to equal the square root of some number, right? I mean, when I plug negative 3/4 in there, that'll be the square root of some number. When is the square root ever equal to a negative real number? Never. So this can't be true. Not true. Not possible, I guess you could say. So turns out that we do have an extraneous solution. This one right here is extraneous. I'll cross that out. Because we plugged it in, it didn't work out. You could have plugged in a number. You just would have had something like the square root of 169 over 4, but it still wouldn't have worked out. Okay. Now let's plug in 5. 5 is the easy one. So 2 times 5 is 10, minus 5 is 5. And 40 minus 3 times 5, well, 3 times 5 is 15. 40 minus 15 is 25. Root 25 is 5. Oh, 5 and 5. Okay, so that works out. So this right here is our solution. It's not always the case that you're going to have an extraneous solution. It just happens quite often, though. So let's try it again. Again, I already know there's no fractions, no decimals to clear out. I can't combine there are no like terms, so I can't combine any terms. And I know that I have to unlock this unknown from this radical, so I'm going to have to square both sides immediately. And when I do that, when I square both sides, I will get 10x plus 5 on the right hand side. And when I square the left hand side, I will get 4x squared plus 4x plus 1. Notice that I didn't write it out slowly, and the reason why is because I want you, if you're confused, to try to write it out yourself. Figure it out how I got that. I can easily see that we're going to have two terms with different powers on x. We'll have an x squared and an x term. So this is going to require special techniques for solving quadratics, which means either factoring or quadratic formula. So let me go ahead and move everything to the left hand side. 4x squared minus 6x minus 4 is equal to 0. Let me make sure my math is correct. Yes, it is. I also notice right away that all of these are divisible by 2, so I'll factor a 2 out. I'm left with 2x squared minus 3x minus 2 is equal to 0. And I'll go ahead and try to factor that trinomial. I know that 2x squared is only factorable into 2x times x. And then negative 2 can either be 2 and 1 or 1 and 2. So I ask myself, 2 times 1, that's 4. I'm sorry, 2 times 1 is 2. 2 times 1 is 2. So we have 2 and 2. Any way to make that into a 3? No. So that's not possible. I'll cross out that one. And then 2 times 2 is 4. 1 times 1 is 1. 4 and 1. Any way to make that into a 3? A negative 3? Yeah, possibly. It is possible if that was a negative 2 there, and that's a positive 1 there, right? Because 2x times that negative 2 will give me a negative 4x plus 1x, that's a negative 3x. So this does work out. So when we factor this, it'll turn into 2 times the quantity 2x plus 1 times the quantity x minus 2 is equal to 0. I have 3 objects multiplying to become 0. Means either the first object is 0, which, well, come on. 2 is never 0. Or the second object is 0. Or the third object is 0. Solving for x, you get x equals a negative 1/2 or x equals 2. And remember, check by substituting these back into the original equation. So let's try the x equals negative 1/2. When we plug that in, we have 2 times a negative 1/2 plus 1. And that will be actually a negative 1 plus 1, or in other words, 0. And the square root of 10 times a negative 1/2, oops, my handwriting's gotten sloppy. Here. Let's see, 10 times a negative half is a negative 5. So that's the square root of a negative 5 plus 5, which is actually 0. Okay, so this does work out for this answer. And now let's try the answer for, let's try x equals 2. That you could do this mentally. 2 times 2 is 4 plus 1 is 5. Okay, so the left-hand side will be 5. 10 times 2 is 20 plus 5 is 25. Square root of 25 is 5. So we have 5 equals 5. That is also a grand old solution. That works. So notice that we can have two solutions. That's absolutely fine. Doesn't have to return an extraneous solution. And now you get to something like this. Now we have two radicals, right? Once you have two radicals, I know they can't combine. You can't remember that square root of a plus the square root of b, I'll even say plus or minus square root of b, is not equal to square root of a plus or minus b. So you cannot combine radicals through addition or subtraction. Just remember that. So these two will not be able to combine up. The best hope you have is to isolate one of them, which actually they're both isolated by themselves on their respective sides, and then square both sides. So let me go ahead and square both sides. So if I square, I'll show the action of it. If I square the left-hand side and then square the right-hand side, I'll get 2y minus 1 is equal to 3y minus 6. Actually a pretty simple equation to solve, right? Subtract 2y from both sides. We get y minus 6 is equal to a negative 1. Oops, my equal sign is a little messed up. And then add 6 to both sides. You'll get y is equal to 5. Now remember, we squared both sides of this equation, so we're going to have to check our answers. Just clean this up so you can see where I'm checking my answer. I'm going to plug in 5 for y here. So that'll be the square root of 10 minus 1, or 9, which we know is going to be 3. And plugging in 5 here, we have 15 minus 6, which is also 9. So we root 9 equals root 9. That works out. There we go. So even though it had two radicals in it, it's actually faster to solve. Okay, so let's try another one. Okay, now we have something that's a little more challenging. We have a radical is equal to a number minus a radical. I know things aren't going to combine, so I'm going to have two different terms involving variables here. I have a term called the square root of 3x plus 1, and I have a term called the square root of 9 minus x, and neither of those cannot be combined up. Again, because of what I just mentioned over here in red, that if I move them over to the same side, you can't glue them together. Remember, square roots can't be glued together through addition or subtraction. So this tells me I'm going to have to resort to special techniques. So because I have more than one version of my variable. So special techniques for solving radical equations, as we've mentioned way back here. Special techniques for solving radical equations: isolate one of them, square both sides, rinse and repeat if necessary. So I'm going to isolate one of them, and one of them is already isolated. I will square both sides. So let me write that out slowly here. I will square the left-hand side, and I will square the entire right-hand side. And again, be very careful when you do this. Always remember what squaring means. It means I have a picture and I'm multiplying it by itself. Well, on the left-hand side, it just means you end up with 3x plus 1. Let me write my implication signs in here. On the right-hand side, it means I have 6 minus square root of 9 minus x times the quantity 6 minus the square root of 9 minus x. In other words, it's this junk inside the parentheses times itself. So you're going to have to simplify that right-hand side. Let's multiply it out. 6 times 6 is 36. Maybe I will even show you the color coding here. 6 times 6 will give me 36. 6 times a negative square root of 9 minus x is going to be a negative 6 times the square root of 9 minus x. Negative root 9 minus x times that 6 is going to be another negative 6 root 9 minus x. And finally, Square root of 9 minus x times the square root of 9 minus x, they're both negative, so it becomes positive. And again, root 9 minus x, it's a half power of 9 minus x, times a half power of 9 minus x, we'll have a full power of 9 minus x, or in other words, just 9 minus x. On the right-hand side here, combine like terms. Always simplify before doing a ton of calculations. So it's going to be 36 minus 12 square root of 9 minus x, right? Because I have a negative 6 of these pictures right here, and I'm losing 6 more of the same pictures, so I've lost 12 altogether. And then finally, plus 9 minus x. Well, I haven't combined all like terms actually. Let me go ahead and add the 36 and the 9 here. This will be 3x plus 1 is equal to 45 minus 12 root 9 minus x minus x. And I see I have a radical equation still, because see, I have a radical with a variable inside of it. So I'm going to isolate that radical, just like we've said way back when. We have a radical equation, isolate, again, square. Right, this is where the rinse and repeat is coming in, because we're actually going to repeat all those steps. So let's go ahead and add x to both sides. I'll stack it nicely. And I'll subtract 45 from both sides. So I'll stack that nicely as well. So this gives me 4x minus 44 is equal to a negative 12 square root of 9 minus x. And there's arguments at this point. Some people might say to divide by that negative 12, and some people might say to not divide by negative 12. I prefer to not divide by negative 12 at this point, because you start getting fractions, and I don't want to introduce fractions into my problem here. So instead, I'm going to go ahead and maybe notice one more thing. Now, what I'm going to do here is not critical that you do, but it does help out in your calculation a little bit. I'm going to notice that on the left-hand side, well, first of all, I'm going to notice that all these coefficients, this 4, this 44, and this 12, are all divisible by 4. So maybe I'll just to make the number smaller, I'm going to divide both sides by 4. Sometimes making numbers smaller is such a good idea. So if you notice that, take advantage of it. So divide every term there by 4. You'll get x minus 11 is equal to a negative 3 times the square root of 9 minus x. And now I will square both sides. And again, I'm not going to divide by a negative 3, even though some people swear that you should or something like that. The fact is, if I divide by a negative 3, I'm going to get fractions, and I don't want to deal with fractions. So I'll just square both sides. Square the left-hand side, square the right-hand side. The only thing you have to remember is that you have two different kinds of squaring actions going on here. You have one, you're squaring a binomial, so that's x minus 11 times x minus 11. And on the right-hand side, you're squaring the product of two numbers. So you have that negative 3 being squared times the square root of 9 minus x being squared. Now, the left-hand side distributes out to x squared minus 22x plus 121 equals, the right-hand side is 9 times the quantity 9 minus x, because the square and the square root cancel each other out. Let me distribute that 9 through. A lot of little paperwork here. 81 minus 9x. I see this is quadratic in the end, so I'm going to go ahead and isolate everything on one side. So I'll have x squared. Let's see, I'm going to add 9x to both sides. So negative 22, and adding back 9 would give me to a negative 13x. Let's see, just double checking my work. And then subtracting 81 from both sides means I'll have a positive 40. Now, this is the easier kind of factoring, because you're just looking for two numbers that multiply to 40 and add to a negative 13. Well, that'd be negative 8 and a negative 5 maybe. So we have two options for x. Either x is equal to 5 or x is equal to 8. Both could be true, one could be true, or none could be true. The way you find out which one is true, or if any of those is true, is you plug those back into the original equation here. Make some room. So if I plug in the 5, I'll get 15 plus 1, or 16. So on the left-hand side, I have the square root of 16, which is 4. 6 minus. On the right-hand side, I have 6 minus, and then the square root of 9 minus 5. 9 minus 5 is 4. Square root of 4 is 2. And if you look at that, that is true. So just checking really quickly, that works out. This is why you have a rewind button, by the way, so that you can kind of pause it, go back, and figure out what I talked about. I talked kind of quickly. So let's plug in now x equals 8. 8 times 3 plus 1, that's 25. Square root of 25 is 5. And I want to know, is this equal to 6 minus the square root of 9 minus 8? It's the square root of 1, which is 1. Is 5 equal to 6 minus 1? Yes, it sure is. So here is another solution, not extraneous. As a final example for solving radical equations, this is kind of like the ultimate style of equation, even though it looks somewhat harmless. The only reason why I consider this to be a more difficult equation is just because, well, two radicals are on one side. They can't combine, and so you know you're going to have to resort to special techniques. And the special techniques, remember, say that if you have a radical equation, you have to isolate one of the radicals first. That's probably the biggest mistake I see is students don't isolate a radical. So you're going to isolate either of these radicals. I'm going to show you the right one to isolate. I would isolate this guy right here. The only reason why is if you look back at our previous example here, notice that when we squared both sides, we had the square root of 9 minus x inside the squaring, and it just created this mess. Okay. Well, if you have the choice of having to square something in the long run, well, maybe I should just show you. Let's subtract root x from both sides. So here's root 5 plus x is equal to 5 minus the square root of x. And now I'm going to square both sides. So if I square both sides, I'll show the action right here. Squaring and squaring. I get 5 plus x on the left-hand side. On the right-hand side, I get 25 minus 10 root x plus x. And now what I'll do is I'll subtract x from both sides. And I'll subtract 25 from both sides. And I get, let's see, on the left-hand side, the x's cancel. And also 5 minus 25 is a negative 20. Equals 25 minus 25, that's gone. And x minus x, that's gone. And actually, since 10 does go into 20 nicely, I'm going to divide both sides by a negative 10 here. Let's divide this side by a negative 10 and this side by a negative 10. And you will see that we get, what is it? Square root of x is equal to 2. So that means that x is equal to 4 when you square both sides. So if you check that out and see if that's true, it actually is, right? 5 plus 4 is 9. Square root of 9 is 3. Plus square root of 4 is 2. 3 plus 2 is 5. Okay, great. That does work out. Let's suppose that you had done this problem the other way, where you said, oh, you know what I'm going to do instead? I'm going to isolate the square root of x, because that looks like such a better isolation. It's not. It's a little uglier, actually. So let's see what happens and why I consider it an uglier isolation. I'll first square both sides, which is the same in both cases, actually. All the steps are the same. It's just it looks uglier in the end. Squaring a square root just gives me x. When I distribute this out, I'll get 25 minus 10 root 5 plus x plus 5 plus x. Let's combine like terms on the right hand side. So I'll have 30 minus 10 root 5 plus x, and then plus x. Let's subtract 5 from both sides, or x from both sides, I'm sorry, and a 30 from both sides. So subtracting x and a 30. There was just a 0, no numbers over there, so no numbers minus 30 gives me a negative 30 equals, what is this, a negative 10 square root of 5 plus x. Divide both sides by a negative 10. You get 3 is equal to root 5 plus x. Square both sides, you'll get 9 is equal to 5 plus x. Subtract 5 from both sides, you get x is equal to 4. Check your work. Now, notice we get the same answer, but there were quite a few more steps actually. This one, we had the isolation step, then we had the squaring step, we had the combining like terms, or basically moving everything to the left-hand side step, and then we divided and squared to get the answer. Here, I moved everything over. I multiplied out, squared both sides. I had to combine like terms actually first, and then I was able to do all the subtractions. And then I did this little division here. And then once I did the division, let's see, oh, these two steps are combined. So once I did division, I still had to do a squaring step and then do another, like subtract 5 from both sides. So there's 7 steps doing it this way. So the rule of thumb is if you have a radical equation, it's a good idea to, the first one to isolate for is the one that has the most difficult stuff in it. Okay, that's a good rule of thumb. Now I'd be remiss if I didn't do a formula solving problem. So let's solve this formula for S. Now notice that S only occurs once in this entire equation. It's right here. It's being squared, but whatever. So if you're asked to solve for a variable that only occurs once, you could just list out what happened to S. And then once you list it out, you can undo it. So first thing that happened to S is it got squared. The second thing that happened to S, is it got multiplied by a negative 1, actually, because there's a negative attached to it. And then the third thing that happened after we attached the negative to it was we added t squared to it. Then we took the square root. So notice all those things that happened to S. So we're going to have to solve for S by undoing these things. So the first thing I'm going to do is undo the last thing they did. I'm going to square both sides because they took the square root of both sides. And then they added t squared. I'm going to subtract t squared. Then they multiplied by a negative 1. I'm going to divide by a negative 1, although multiplying and dividing by a negative 1 are the same. And then finally, I will have to take the square root of both sides. So let's go ahead and do these right here. So first thing I'm going to do is square both sides. Now when you're dealing with formulas and a bunch of variables, you're not really going to mention the fact that you possibly have an extraneous solution. It's just not going to happen here. So you don't have to worry about that. So we just get r squared is equal to t squared minus s squared. I tell myself now I'm going to subtract t squared from both sides, because we just finished this step. So r squared minus t squared is equal to a negative s squared. Then I tell myself that I'm going to divide both sides by a negative 1, which essentially means just flip the signs on everything. So I have a negative r squared plus t squared is equal to positive s squared. And then take the square root of both sides. In the square root, remember, if you're solving for a variable s and it's being squared, when you take the square root of both sides, remember the other side is going to be plus or minus the square root of negative r squared plus t squared. And that's as good as it gets. You can't really do anything else with that. By the way, this video took me 3 days to record. I've had pneumonia, so but I made it through it.